Today, we have the outdoor PCB of a mini-split air conditioner. First, I'll explain the mistake. Then we'll check what fault has occurred in this PCB. Here's what happened. The AC unit was serviced while the PCB was still installed in the unit, which allowed water to get into it. After the service, when the unit was turned on, there was a blast sound and the unit shut down. Now, we'll test this PCB to find out what fault occurred. A suggestion for you: never service the unit with the PCB inside. Either cover it with a plastic cover, or the best approach is to remove the PCB and service the unit separately. This way, the PCB and all the electrical components are protected, saving you from bigger problems. Let's go ahead and start fixing it. So let me tell you that when the PCB of the outdoor unit in this air conditioner fails, it shows an E5 error. Currently, we're also seeing the E5 error, so let's start testing it. First, we'll set the multimeter to continuity mode. The first main component to check is the fuse. After checking, we can see that the fuse is perfectly fine, which means the problem could be further down the line. Looking at the PCB physically, I don't see any visible damage, so I'll need to check each component step by step. Now let's check the PTC sensor. I will set the multimeter to resistance mode and place the probes on the PTC. As you can see, it's showing 46.3 ohms, which is perfectly fine. Next, let's check if any of the capacitors are faulty. We'll test them separately by applying power, but before that, it's essential to check the rectification and its SMPS. We'll set the multimeter to diode mode, place the probes, and check. It's showing the voltage drop for each point of the double diode, and the next points are also fine. All the diodes are good, but let's reverse the polarity and check again. There's no zero reading on any point, which means everything here is functioning correctly. After this, the electricity flows to the compressor drive system. There's also a resistor here, a shunt resistor. If this shunt resistor fails, it can also cause issues. Let's check it now. It's a 10 milliohm resistor. If any excessive load comes through, this resistor can short or burn out to protect the rest of the system. We'll set the multimeter to kilo ohms, place the probes, and check. It's showing 0.3 ohms, which is perfectly fine. This means the resistor is okay, so the problem could be in the drive area or the SMPS. We'll need to check these components next. Now let's check the SMPS to ensure there's no issue with it. The diodes here could potentially be faulty, so let's check them by placing the probes. These diodes are fine, and there's another diode near the switching IC. Let's check that one too. It's also in good condition. Let's reverse the polarity and check again, and it's still showing correct readings. Physically, there's no visible damage on the SMPS, the chopper, or the switching IC, so everything appears intact here as well. Now, let's check the IPM, its diodes, and the IGBT to ensure none of them are shorted. If any of these components were shorted, the system wouldn't function properly. First, we'll check the IPM. I've already covered how to check the IPM in a previous video on the channel, so you can refer to that for more details. Right now, I'll check quickly. As you can see, the readings are fine across all the points. I'll change the probes and check each point, and they're all showing correct values with no issues. Now let's check the diode. If the diode is faulty, the system won't work properly. After testing, we see that it shows 0, but when we change the polarity, the diode is perfectly fine. Next, let's check the IGBT. Upon testing, it shows 0.21, and when we check the third point, it shows 0 here. After changing the polarity, it still shows the same reading. This means the IGBT is shorted. Now that we've removed the IGBT from the circuit, let's test it separately to see if its condition is clear after being taken out of the system. We'll check it in diode mode. As you can see, it's showing 0 in the same position, which means the IGBT is indeed burnt out. So what we'll do next is replace the IGBT with a new one and test the system to see if it works properly. Now, we've replaced the IGBT with a new one, as you can see. Let's test it with the multimeter to make sure everything is working correctly, and the 0 reading has disappeared, and it's now showing 0 voltage drop. I changed the probes and checked again, and everything seems perfect. This confirms that there's no fault left. Now, as you can see, I've made all the necessary settings, and the multimeter is set up to measure the voltage so we can see how much power is coming through. The reactor and all other components have been installed. We'll apply power now, and you'll notice that the light will briefly turn on and then turn off because there's no fault remaining in the system. All the sensors have also been installed. If the sensors weren't installed correctly, or if there was a problem with the IPM, the lights would blink. When I applied power, the light turned on briefly, then off, and the voltage reading showed 224 volts. I also heard the switching sound, confirming everything is working as it should. I will remove the thermistors. As soon as I took them out, the lights started blinking. This confirms that the PCB is now working correctly. Now I'll reinstall the sensors and everything will be fully functional. Click on the left or right thumbnail to watch our next videos and subscribe. Thank you.